viewers, welcome to another session of your MOOCs course Internet of Things, Design Concepts and Use Cases. In today's session, we are going to talk about interfacing LDR and LED with Arduino. As you know, in the previous videos, you might have learned about interfacing or controlling intensity of a LED with the help of potentiometer. Today's experiment is slightly different to that. Here we are going to talk about a light dependent resistor. As you can see on the screen, we have a light dependent resistor over here, which changes its resistance based on the intensity of light falling on it. And based on that light intensity, it can further control different devices based on your circuit. So, here we are going to design a very basic circuit. I am going to use a LDR on one pin of Arduino, and on the other pin of Arduino I will be connecting a LED. Based on brightness and darkness level at your LDR terminal, we will further control the intensity, or we can say the on and off condition of LED. So, in order to do that, we simply need these three main equipments. One is your LED, other is your Arduino, and then we need LDR. So, as you have seen the circuit diagram on your screen, on any one of the analog port I will be connecting this LDR. On any one of the digital pins I will be using my LED, and in sequence to that I will be creating a code to interface this entire sequence. So, let us see all these connections on the hardware side now. For this, I have first connected one LED on my breadboard, and at the same time I have obtained this LDR device. It has 3 pins, as you can see. One of these is your VCC, which you can connect to 5 volt, other is your ground pin, and one more we have is signal pin. This particular signal pin we will be connecting to any of your analog pin on your Arduino analog port. So, let us make our first connection with this LDR terminals. I am picking up the ground wire and I am putting it inside one of the ground terminals on your Arduino, and next to this I am picking up the VCC terminal and I will be using it on 5 volt terminal on ground, and there is a signal terminal that I am connecting on A0 pin of your Arduino board. So, these are our 3 basic connections. Next to this, I have to connect this LED with specific terminal on the board. So, first of all, I need to identify the anode and cathode terminal of LED. So, as you already know, we just have to check the size of the flag inside this LED. So, for the smaller flag, that will definitely be your anode terminal. I am using this red wire, and for the cathode terminal I am connecting here one black wire. So, this red one now I will be taking further to your signal pin, on which I will be creating my interface with the help of your LDR. So, let us consider one of the pin from the digital port I am using here from this downward portion, and the other terminal I will be using on the ground terminal over here. So, these are your basic connections ready on your hardware side. Now, for the same interface, let us design a code, and for which I will be taking you further to your favorite software, that is Arduino IDE, and on this I have created a very small sequence. You can see here. First of all, we will be creating a void setup section, because this particular sensor does not require any library. So, you can see I have not included any library in the beginning of this code. It starts directly with the setup part, and here first I have started communication with the serial monitor with your 9600 baud rate, and after this I have declared pin number 4 on the hardware side as an output pin. This will be from digital port. Next to this, we are switching to the void loop section, where first of all I will be getting my signal from pin number A0, which in this case I have declared as an LDR pin. So, we are reading directly your signal in S1 variable from this analog read function. After this, I am simply printing this value on the serial monitor, and at the same time I have added a delay of 500. That will be a very small delay to interface this particular sensor. And after this, we have created a condition that will be your if condition, stating that if the signal value is less than 500. This one is basically a threshold set in your coding platform. Why this threshold? Just to organize the brightness as well as the darkness level on your LED terminal. So, depending upon how the resistance of your LDR is varying around this threshold value, which is 500, accordingly you will see that LED will glow or it will turn off. So, both readings we will see on the software terminal as well as on this hardware. Next to this, based on the if condition, I have added a digital write sequence to turn your LED in one direction, that will be in on condition, and then otherwise in off condition. So, this is the entire sequence of code we have created over here, and next to this now we are ready to interface it to our hardware terminal. So, first of all we need to verify that your connection is right. So, let me check if we have connected LED on pin number 4, that will be first we have pin number 0, 1, 2, 3 and 4. So, this is right, and similarly on A0, that is your first most pin on the analog port where I have connected my LDR. So, the same sequence we have in the software. Now, simply we have to plug in your USB terminal, and I am just inputting it here. After that, as you know, we have to check the tool section, and you can see the port and board are connected right here. Next to this, we can go ahead with the upload. So, I can just click on this upload button. It will first compile my sketch, and after that it will be uploaded on the board. So, as soon as your code is ready, we can demonstrate it on the hardware side. So, currently you can see this LDR we have here in hand, and it is showing continuous values of resistance on your screen. This is considering the light intensity at this particular position. Now, let us assume a case that you are designing this particular circuit for a light control system, whether it is outdoor lighting or indoor lighting. So, let us consider a outdoor lighting system same as your street lights you are trying to create. So, when it goes dark outside, your LED or that street light should turn on automatically. So, it means when your LDR gets into dark position. So, I am just closing it with my hand, and you can see the LED turns on instantly, considering that there is darkness in the environment. And as soon as sun comes again in the next morning, so there will be brightness, and the light, your street light will be turned off automatically. So, you can see how this small sensor can demonstrate you a very interesting concept, and based on this only the street lights throughout your cities and villages are being designed, and you can have several high end sensors based on the same concept to control lighting management in different urban and rural areas. So, this was one of the interesting experiments that we have done, and we will meet again with some new experiments on your Arduino board. Thanks a lot for watching this video.